So very nice to talk to you all about what we've been doing in South Australia on out-of-field teaching in mathematics. So I'm going to talk about some work that Lisa and I did to better understand the diversity of those teaching in Years 7 to 10 mathematics in Department for Education schools in South Australia, and particularly those who are deemed to be out of field. So last year I presented at OOFTAS an analysis of the results of the survey. And this year I want to talk about taking an identity lens on the data, which we did through a combination of following our nose and following the data. And I'll talk a bit more about that in a moment. Oh, this may or may not work. Let's see how we go. Okay, so I don't need to tell everyone here that this phenomenon spans the globe. In Australia, it's thought to be greater than in other comparable countries, but the statistics we have give an incomplete and often out-of-date picture of the situation. So, for example, you can see that if we look at mathematics teachers, data from 2018 suggests that at least 40% of mathematics teachers were potentially teaching out of field. When you look at mathematics classrooms, Paul Weldon's 2013 data looked at that, and then AMSI, the Australian Mathematical Sciences Institute, used Weldon's data to develop a mathematical model to suggest that there's a 76% chance of being taught by at least one out-of-field teacher in Years 7 to 10, and that less than 1 in 4 Years 7 to 10 students have an in-field mathematics teacher every year. So different data, a bit out of date and telling us different parts of this situation. Out-of-field teaching is often equated with poor mathematics teaching, but labelling teachers as out-of-field is complex. So the common definition, as we all know, centres on criteria that's used to qualify and or register teachers, and it's a static definition that predominantly describes a teacher at the start of their career, ignoring that teachers develop and grow throughout their career as they gain confidence, experience, and perhaps further qualifications. So a teacher may have initially been trained in maths, may initially not have been trained in maths, but they've engaged in self-study and attended professional development, and they're comfortable and competent in the content. And so labelling that teacher as out of field may be unwarranted if it's taken to mean an ineffective mathematics teacher. So I'm sure you're all very familiar with Linda and colleagues' multifaceted definition of teaching out of field, and this is what we've used in our work. What I like in particular is that the focus of out-of-fieldness, as I think you say, Linda, shifts from the teacher to the context of the teaching. So it's being out of field by workload, for example, that recognises that it's the assignment of the work to the teacher, not the teacher themselves who is mismatched. You can also flip the script on out of field by capability to talk positively about a teacher's growing identity within a new context. And so we talk here about highly capable out-of-field teachers as ones who are capable in the out-of-field subject, have a high degree of confidence, have a personal interest in the subject, are professionally committed to developing and reflecting on their practice, self-identifies as proximal, and has accepted the role long-term, expanding their professional identity into the role. So in the work we did, which was an anonymous survey, we couldn't assess how capable the teacher was in the subject content, but we did examine the remaining 5 aspects. So to give you a brief background to the research, we wanted to understand these 5 research questions. There's a lot there. So teacher demographics, what are teachers' beliefs around what counts as out of field? Number 3 is the one that's particularly relevant to what I'm talking about today, and then their challenges and key supports. So we conducted a survey in late 2022. It was hosted on Qualtrics and distributed by the South Australian Department for Education, and it lined up to previous surveys that had been conducted in the past. There were 272 responses to the survey, 232 of which we included, and then after some, that was after data cleaning, and then 196 of those respondents were currently or had previously taught Year 7 to 10 mathematics in South Australian schools. So we asked respondents a whole number of different questions, but when it comes to things around identity, we asked, well, we've pulled out 2 direct questions about identity and we've inferred a 3rd dimension. So last year at OOFTAS, I talked only about the first 2 questions. So do you consider yourself a mathematics teacher? And unsurprisingly, the majority of what I'm going to call Quin teachers, so infield by qualification, identified as mathematics teachers, but only 2/3 of QUIF teachers did. That's a bit unsurprising. The second question, do you consider yourself an out-of-field mathematics teacher? Well, as you might expect, if they're infield by qualification, almost all teachers identified as not out of field, which we've referred to as identifying in-field, even though we didn't actually ask them that question. What's more surprising, perhaps, is only half of teachers who were out of field by qualification saw themselves as out of field by qualification. The other half saw themselves as in-field. So it was interesting to unpack how they defined an out-of-field teacher of mathematics. And the in-field by qualification teachers gave definitions that centred on formal qualifications, but the out-of-field by qualification teachers mentioned a greater variety of other factors in their definitions, such as lack of experience teaching or discomfort or things like that. And I talked about that last year at OOFTAS. In terms of the 3rd question, it was when we explored workload through an identity lens, which I'm not talking about today, that we started to wonder if identity was connected to whether or not someone preferred to teach mathematics. So we went back to a question that we'd asked, which was, what is your preferred learning areas to teach? And then if someone mentioned mathematics, we counted them in, and if they didn't, we didn't count them. And then we went back to our earlier analysis to consider the effect of all 3 dimensions on teacher identity for the criteria that we had data for. And that's what I'm going to briefly talk about. So here are the 18 factors that we investigated. We drew on Linda's definition of out-of-field by capability to do this. For the first 6 capability factors shown on the left, teachers gave responses on a scale from 0 to 5. And then for the remaining 12, teachers rated their confidence as low, medium, or high, which we turned into numerical scores, for better or worse. Now, that middle column that talks about confidence in teaching various year levels, we actually went further than that and asked them about the 6 strands in the Australian curriculum mathematics, but I'm going to leave that out. So this is what we did, and this will give you the big picture overview of the data I'm going to show you, because we can get lost in a few tables. And I'm going to be honest and say we didn't actually have a research question. What we did was have a look at the data and see what it told us in terms of these 3 proposed dimensions. So the first thing we did was compare in-field by qualification and out-of-field by qualification teachers to see if there were differences in factors for each identity dimension, and there were. And then we thought, if we just look within the out-of-field by qualification teachers, are there differences? And do these identity dimensions interact in particular ways? So we have 3 identity dimensions, and you can either be yes or no to them. So there are 8 possible cohorts to consider. And then we're going to finish by asking whether any of these cohorts are statistically different from in-field teachers. Okay, so the first one, Quin versus QUIF. So here's the data. So let me just orient you to it. So the first 2 columns in blue are whether or not these teachers identify as in-field. The next 2 are whether or not they identify as mathematics teachers and then prefers to teach mathematics. And then we have 6 of the factors shown in the rows on the left. And what I'm reporting here is the mean score for that group out of 5. So remember, where 0 was low and 5 was high. And now what I'm going to do is put in bold those that denotes where the difference between the means is statistically significant. And we use two-tailed Mann-Whitney U tests to determine if these mean differences were statistically significant. So perhaps unsurprisingly, if you prefer to teach mathematics, there is not statistically significant differences in your personal interest in mathematics, for instance. And interestingly, there were no statistically significant differences in enjoyment teaching mathematics across the board. And you can see that because that row is grayed out. So it means it wasn't statistically significant. But everywhere else that it's bold and in black, there were differences. So for instance, identifying as in-field, there were differences, statistically significant differences in confidence and content knowledge, depending on whether you're in-field by qualification or out-of-field by qualification, and so on. We see no statistically significant differences in confidence teaching year 7, and in some cases, out-of-field teachers by qualification have a higher mean confidence, which might seem surprising, but in South Australian schools, year 7 moved from primary to secondary in the year before the survey was conducted, and so we think those out-of-field teachers probably thought, actually, this is pretty easy to teach. Okay, so we've also looked at proficiencies and processes in the Australian mathematical curriculum, and there are statistically significant differences almost across the board. But it is worth noting that the mathematical processes, the last 4 rows in this table, were pretty unfamiliar to all teachers when the survey was conducted, because it only just come into the Australian curriculum. So the summary from this section is, when we're comparing in-field to out-of-field just by qualification, there were statistically significant differences across many of the 18 factors. But importantly, there were no statistically significant differences in the following things. So if you identified as in-field, there were no differences in enjoyment teaching maths or teaching year 7 maths, and you can see the other categories there as well. Okay, so the next step, we thought we'd look closer just at those who are out of field by qualification and see if there were differences. So here I'm showing you the same kind of data as before, but now we're using our 3 identity factors just within the out of field by qualification group. So what's interesting here is there are statistically significant differences across almost all aspects, even though we're only looking at those who are out of field by qualification and just adding 1 extra dimension, whether or not they identify as in-field, whether or not they identify as mathematics teachers, and whether or not they prefer to teach mathematics. The only places, as you can see, where there were no statistically significant differences were in the teachers who were identifying as in-field by as in-field. It was their commitment to developing their content knowledge and their pedagogical content knowledge. And you can see that those who don't identify as maths teachers have quite low commitment to developing their content knowledge and PCK compared with those who do. So you can see that in the 1.91 and the 2.33 in the last row of this table. So they are very low scores. Similar kinds of things to notice about confidence in teaching each of the year levels. Again, look at those very low scores for teachers who don't identify as maths teachers, and within the proficiencies and processes. Again, statistically significant differences almost across the board. So the summary here is that these different identity factors are significant, and they tell us different things about the cohort of out-of-field teachers by qualification. So I'm not going to go into the reasons why, but we decided in the end to exclude self-identifiers as in-field from the remainder of the analysis, partly because teachers didn't really understand what in-field and out-of-field meant, but also some of the statistical analysis showed us that it wasn't so important. So what that left us with was 2 identity dimensions: identifies as a maths teacher and prefers to teach mathematics. And this gives us 4 different cohorts of out-of-field teachers to consider. And I've put a summary there on the right of what this looks like for each of those 18 identity factors. Cohort 1 had the highest means across 16 of those 8 factors. Cohort 4, those who don't identify as maths teachers and don't prefer to teach mathematics, unsurprisingly demonstrated very low means across all 18 of those factors. And they're probably the ones who many are implicitly referring to when we use the term out-of-field teachers. They're very disconnected from the subject and they don't enjoy teaching it. But it's at this point, sorry, I didn't bring that one up. It's at this point that we can really ask our research question, which is, are these various cohorts of out-of-field teachers statistically indistinguishable from in-field teachers when we consider these 18 factors? So what we're going to do is look at cohort 1, those who identify as maths teachers and prefer to teach mathematics, and compare them to in-field teachers and see if there are any statistically significant differences. So let's have a crack. The first 6 factors, there are no statistically significant differences in those comparisons except for their confidence in content knowledge. For everything else, yeah, and Linda went, oh yeah, and it's like, I agree, that one's not surprising. But what is surprising to me is that there's no differences for the other 5, right? That they have the same kind of personal interest in maths, they enjoy it, they're committed to developing, it's just their confidence in their content knowledge. Confidence in year levels, no differences at the lower years, differences at the upper years, which is where I'd argue your content becomes arguably more challenging, and so those things are connected. And then the processes and the proficiencies, it's a bit scattergun here, but the understanding proficiency, I'd argue, is tied to content knowledge. And as I said before, when it comes to the last 4, the mathematical processes, they were pretty new to all teachers. So I'm not sure what conclusions we can draw there. So that was our question, and the answer was yes, they are statistically indistinguishable with the exception of confidence in content knowledge manifested in various ways. So you kind of get to this point and go, well, that's not really surprising because they're the ones who are out of field by qualification. But what is surprising is that they don't appear to be different to in-field teachers on a whole lot of other dimensions. So if we come back to Linda's definition of highly capable out-of-field teachers and line this up, well, we didn't examine whether they were capable / competent in the subject. They have a high degree of confidence. The difference was only in content knowledge. No difference in personal interest, in their commitment. They self-identify as proximal to the subject because they prefer to teach it. And I would argue they've expanded their professional identity to include the role because they see themselves as mathematics teachers. So what? A few summary points, none of which I think I haven't already covered. Probably the key point here is some out-of-field teachers share many characteristics with their in-field counterparts. We can't say anything about the interplay between identity and competence, but we actually can't say that for in-field teachers either. And a suggestion that we probably need to look at these cohorts, sub-cohorts of out-of-field teachers when it comes to professional learning. And the now what? What are we going to do next? We want to know more about each cohort. So we're going to repeat the survey and then follow up with opt-in interviews so we can get more information because we want to know more about each cohort and their responses. What do they think is meant by a mathematics teacher? For some people, they'd be like, well, I teach maths. Of course, I'm a maths teacher. And for other people, that's a far more connected to their own identity about both mathematics and about teaching. Pedagogical content knowledge. I'm getting the sense that some teachers don't actually know what we mean when we say that. Why do they prefer to teach mathematics? Is their identity more proximal to their original learning area? And Kate Challen, who's in the chat, gave me that idea at Merger. And in particular, we want to know more about cohort 1. How do they see themselves? And what was their trajectory? How did they get from being an out-of-field teacher to now basically seeing themselves just like in-field teachers of mathematics do? So that was the last point there, and that's it. Thank you very much.